Hey guys, this is Sujayram, and here is Philip Babbage from Croatia. And today's event's topic is about advanced side of Kotlin. And if you have any questions, you can submit the questions through the link in the below in the description. And yeah, let's get started.
Awesome. Well, thank you for announcing me, and again, thanks everyone for joining. This is basically the next presentation that I usually hold after the introduction to Kotlin, which is the advanced side of Kotlin. And before we kind of dive into the presentation, I just want to say that Kotlin as a language is very broad. There's so many topics, so I'll try to touch up on some of the topics in Kotlin that are more advanced from the programmer side, let's say. Where they touch upon the objective-oriented side and the functional programming side. So again, I won't be able to cover absolutely everything because the language is so big, but at the same time, I'll try to do my best to cover the most important bits. So let me just move you to the side so I can share my screen. You should be able to see my screen already, right? Yeah. Okay, so thank you again for joining. So my name is Philip Babbage, as Sujay mentioned. And I'm a Google developer expert for Android and Kotlin. And today I'll talk a bit about some of these topics in Kotlin, which are generally connected to objective-oriented programming or functional programming. And those are inheritance, interface, delegates, Lambda, and higher order functions, as well as polymorphism, abstractions, override and overload types of functions, and collections and operators you can run within those collections. So let's kind of quickly dive into it. So when we talk about inheritance in programming, we generally talk about the ability for one class or one structure to define some behavior that can be reused when the behavior is inherited through, let's say, overriding those functions or implementing them if you're talking about an interface, which we'll get to in a moment. So interface basically means the ability to transfer behavior from one class to another through different mechanisms. So in Kotlin, there's this thing where you can't really inherit any class by default. They are closed for inheritance or for extension, so to say, by default. So you have to add the open keyword at the very start of the class. Sorry. And the only thing that you can, or the things that you can inherit from the parent class are only the things that are non-private. So you can't really inherit private behavior. You can inherit protected, internal, and public behavior. And inheritance creates this hierarchy where you know what the parent is, and you know if the parent or the current class has any subclasses. The syntax for inheritance is this. It's very simple. So basically, you define a new class, and using a semicolon, you say, this class is going to inherit from the parent class. You have to pass in to the parent class's constructor any parameters that class requires. So let's see how it looks in an example. Let's say we have an open class called person. A person has a name and a last name. And because it's open, we are now open for extension. If the open keyword wasn't here, we couldn't be inheriting this class. We also have a class called job, for example. Each job has a name and some salary, I guess. And now we have an open class called worker. The worker class receives three parameters: the name, the last name, and a job. But it also inherits from the person, which means that it has to pass in the name and the last name to the person class. So what's going to happen here in the worker class is that it's going to have these two properties, in the worker class. It's going to have these two properties from the person class, and it's going to be attached to the behavior of the worker class. But it's also going to have its own property that's not defined in person, called a job. That's basically a new property that's defined within the worker class. You can also go on a level higher or lower, I guess, however you want to depict it, where we have a teacher class that has a name, a last name, and a salary. And this behavior or this state is actually propagated to the worker class, which it inherits from. It sends the name and the last name to the worker, so it knows how to populate the person class or these two properties. But it also sends the salary to a job property of the worker class because it extends from that behavior or it inherits that behavior. And because we know that the job is always going to be a teacher, we just need to define the salary property here. So this is a way that inheritance works. Basically, you just have to propagate any parameters to the parent class within the primary constructor, which is inlined. And these properties need to fill in, so basically like in a cascade way, they need to fill in all the parent classes. So here we can see that the teacher filled in the behavior and, well, the state of the worker, and the worker filled in the state of the person. So now all of these three classes, I guess, are now filled, and you have this complex teacher object that actually has multiple properties, but it doesn't actually define any properties within its primary constructor. It just inherits those properties from the classes it inherits from. Similar to inheritance, you can use interfaces to define some behavior or define a contract where a class that implements the interface is going to override or implement this behavior. We'll see what this means in a moment. So basically, like an interface is very similar to a class, but it's always abstract, so to say. And abstract functions or abstract properties mean that these need to be implemented. So they are abstract in a way that there's no concrete definition yet. So you have to define this behavior or state in the place where you actually implement this interface. One really big difference between classes and interfaces is that you can only inherit from one class, one parent class, but you can implement any number of interfaces, which means that interfaces are a bit more powerful in that sense. So you can add any number of interfaces to your class, but you can only inherit from one class. So interfaces are more like composition, where you compose multiple different types of behavior or state, whereas obviously inheritance is inheritance. So you have these two concepts of sharing behavior, which is composition and inheritance. And you should always try to favor composition. When we say that interfaces have to be abstract, that's not completely true. You can also define functions in an interface, and you can also define default behavior. This is something that's, I won't say it's used too often. Basically, it is very useful. You can use it for very specific cases. But generally speaking, when you have interfaces, you want to define some behavior in every implementation, because you kind of want to say that this is a unique implementation of the interface. So let's see what it means. So if you're coming from like the Android world, let's say you have these interfaces defined, which are very common in Android. So you have like an on-click listener, which describes a function called onClick. You also have a onLongClick listener, which describes a function called onLongClick, or it defines this function. So you can see these interfaces, these two interfaces here, don't have any implementation. This function doesn't do anything on its own, as well as this function, right? You can also combine multiple interfaces, as I mentioned, because you can inherit from them, essentially. So here in the combine click listener function, combine click listener interface, you inherit or implement both of these interfaces, which are onClick and onLongClick listeners. So this one interface has now these two functions defined within it, so to say. But we still don't have any concrete behavior. We still haven't implemented the interface anywhere. To do that, what you need to do is similar to with how you did with classes and inheritance. You just say, okay, I have my class called custom listener, and it's going to implement the combined click listener. The main difference between implementing an interface and inheriting a class is that when you inherit a class, you have to call the primary constructor of that class. That is because you need to like instantiate that object or that section of the object within the current class that's inheriting it from. With interfaces, because interfaces are abstract, and there are no like objects or primary constructors for interfaces, You don't call any constructors here, but you do have to implement and override any behavior that hasn't been defined yet. So basically here within onClick, you just say, okay, within this interface, I have a class called, or sorry, I have a function called onClick, and it's an override of these two functions here. So same for the onClick. And you can define any type of behavior here. So your custom listener might want to open a new screen. If you're talking about an Android app, you might want to print something if you're clicking on an item. You might want to show a dialog if you're long clicking on an item, and something similar. Basically, anything that is close to your application. But the unique part about this is that you essentially can define any type of behavior. You can essentially have the same interface implemented in multiple places, but with different behavior. And this is what's so powerful about interfaces. So one onClick listener might do one thing, another onClick listener might do something completely different, which is really cool thing about interfaces. Whereas in inheritance, you have to define something that's clear. And usually when you reach the end of the inheritance line, I guess, that behavior is not really going to change. So let's talk about abstractions and polymorphism, basically. These are two very, very important concepts, and these are very commonly used concepts. So with all of this talk about inheritance and in interfaces or composition, actually goes along with abstractions and polymorphism. These two concepts basically mean that you can use one instance of one object as multiple different types. So let's go back real quick here. Here with the custom listener, this class type is actually 3 types, or 4 if you look at it. Its type can be custom listener, its type can be combined click listener, but its types also can be onClick and onLong click listener, because it incorporates all of these 4 types into one class. And we'll see how this actually works. This is very useful when you have base classes or abstract interfaces and you want to just focus on one type instead of multiple types, or you don't want to define the entire behavior or expose all of the API to your user. You just want them to know that you're using one small part of your behavior. So it's really good for that, but it's also really good when you have similar behavior, so you want to group them together, but it can cover different implementations. So let's see what this actually means. It's a bit abstract, as you might know this. So let's go back to the interface that we defined. Well, this is a bit similar. So we have an interface called click listener, just simple click listener. It has a function onClick. We can implement 3 different types of these listeners. So we can have an image view click listener. So when you're tapping on an image, we can have a text view click listener when you're tapping on a text item on the screen, or a button click listener when you click on a button, basically. These 3 functions onClick all do something different, which is the point of interfaces. So the image view click listener might show a small toast or a message that shows the content description of the image view. The content description is used for accessibility. So basically it defines what the image is without if you're not able to perceive the image through visual means. The text view might read the text in accessibility. So if someone is, again, visually impaired, you might want to read the text to them because they won't be able to consume the text otherwise. And the button click listener is just performing a click. What we can do with this is we can create a list of these 3 listeners, and we can here in a for loop call onClick on each of them. So what's really good about this, what's awesome about this, is that the type of these listeners is click listener. And the for loop doesn't really know if you're using, or this small piece of code doesn't know if you're using an image view click listener, a text view, or a button click listener, or anything else. It just knows that these 3 objects, I guess, have one type in common, which is the onClick listener, and you can call the function onClick. This is called the iterable or iterator pattern, basically, where you go over a list of items or a collection of items and call the same behavior on them, but they might have different implementations underneath. Similarly, here we can define an interface called consumer, which has two functions. If you can consume an item and to consume an item, and if you can consume an item. So for example, we can define a string consumer, which just checks if whatever data we're sending to it is a string, and it's going to consume it by printing the string in like a nice format. Then a person consumer, and this sounds a bit weird, can only consume a data type if the type is a person, obviously. And the way it consumes it is if it checks if the person name starts with an F, and we print this may be Philip, but it might be someone else. It might be Ferdinand or some, I'm not sure. I don't know too many names on the letter F. So basically what we define here is two implementations of the consumer type. But again, we can go through a for loop and iterate over these consumers and call the same behavior. And different things are going to happen based on the data that we send, even though it's the same interface and the same type. So again, to kind of reiterate over this is you can use abstractions and polymorphism and concrete types and abstract types and interfaces and inheritance to define many different design patterns. There's a really cool website that I can actually link at the end of the talk or something, where you have these design patterns defined and what they are like commonly used for. Basically, they are generally used to reduce the complexity of your code and help you simplify like the syntax and to actually help you build the logic that you need without like having too many complex checks or anything like that. They're really useful, and you might not know what design patterns are, but you're most probably using them. Or if you're using them already, you might not know which ones you're using, but they are still present in your code. So I can share like that link and you'll see which ones you're actually using or not. So in terms of override and overload, we've already seen a bit of this, but let's just dive into what that means. Basically, these are two ways you can change the behavior that already exists. So override fully changes the behavior and it replaces like the existing behavior in your code to something else. So for example, in the inheritance part, or when we use interfaces, you overrided the functions or overrode the functions, meaning that you change the base behavior or the parent behavior to something new. So with interfaces, it's always overriding the function because the function isn't usually defined. With inheritance, you can override the function, but you can also call the default behavior by referring to the parent class. This is usually called like a super call or like a parent call or something similar, where you call the behavior that's already defined. But you can also just call the custom behavior. Overload is a bit different, where you have the same behavior, so to say, or it looks like the same function, but the parameters and the signature might be a bit different. So this usually means that you have a different number of parameters, or their types are a bit different, or they might be in a different order. So let's see how it looks like. Again, so if we have a person class here, we have a function called toString. Notice the override keyword here. This means that the function is overridden by this class. ToString is defined on the parent class called any, or object in Java, which means that if you override it, you're going to change the very basic behavior of the toString function. This is what you usually want to do, I guess. So here in the person class, we just say, okay, when we call toString on an object of the type person, we're going to say my name is, and we're going to format it name, last name. So it's going to say, for example, my name is Filip, Babic. We can then have a worker class like defined before, which has, and the worker has like a job, obviously. And we can override the toString function, not to call this one, but to call this one, so something different. And it's going to say my name is, again, name, last name. And it's also going to add this part where it says, and I work at job.name. So it's going to say my name is Filip Babic, and I work as a, well, I guess Android developer, or if you want the full title of my full title, but it's a bit lengthy. So it will basically say the name and last name and the job title, which is really cool. So now we have this class where, or this behavior where one class defines something, and then when you call it in a like a child class, it knows that the behavior is overridden, so you can show something completely different, but it's the same function call. And finally, we can go to like a teacher class, and because teachers usually use this like notation of Mr. Babic, or something like that, or Ms. Babic, I guess. We format the toString function to be this. So my name is Mr. or Miss, and then last name. Basically, this kind of defines that this person is a teacher, because teachers usually use that notation. But here we can like clearly say what the job title is. That's overriding behavior. So where you take one function or a property that's been defined somewhere else, and when you inherit it, you can completely override it to do something different. Now, this is overloading. We have a function called sum, for example, which is just the sum of two numbers. But here we have two float numbers, and it returns a float. However, we also have an overload of that function, where we have two integers, and we return an integer. Basically, this is an example where you have behavior that works for one type, but it can also work for another type. However, you have to differentiate the types, because you can't, like, if you just returned, if you take in floats here, but you want to set integers, it's not going to work. So this is why you also need a function that does the same with integers. Has the same signature, has the same, the same return type, but for integers. The behavior is probably going to stay the same. That's what usually happens with overloads. The behavior is the same, but the parameters or the return type are not. So this is overloading behavior. Let's go to something a bit more complex, I guess, which are Lambda functions and higher order functions. Usually in most languages, you're used to this idea where you just call functions, or the functions are connected to a class, and you call them through objects of that class. But in Kotlin, you have this idea, because it's like a modern language, it's using modern features, even though these features are like 50 years old. You can define functions which are which are types of data, or you can define like objects of a function type, or you can send functions as parameters. And finally, functions can be defined outside of a class. So they're like first class instances. They're in a file instead of a class. All of this behavior is called higher order functions generally, whereas Lambda functions are functions that you define as objects or as parameter types. So let's see how it looks like. So here we have Here we have a basic Lambda function where we call the filter function on a collection list, and we'll come to collections in a moment. The validator parameter here is called a Lambda function. Notice how you open the parentheses here, and you can define some behavior within. This is called a Lambda function because it doesn't have any name. That's kind of like the definition. It doesn't have any name. It doesn't have any like origin point or anything like that. You just define it in line, or you define it as a function object somewhere, and you send it to the function that you're calling. Alternatively, you can also use like this nice, clean, shorter notation where you don't use parentheses. You can just like expose the Lambda function outside, or say, I want to filter my users for users which contain the letter A. This is really simple, and it's really intuitive when you read it. But it's a bit scary at the first time you start using these functions, because they are completely they're a bit weird. So basically, you define a function somewhere, but it's not used in the place where you call it. It's used somewhere else. It's passed a different function. So for example, here in the function called do if connected to internet, we pass in an action. The action is a function type. You just say this is a function that doesn't receive any parameters, and it returns unit, or it returns void in Java. Doesn't return anything, I guess. And then you can say if is connected to internet. This is like an internal check we have. Call this action. So now you can see that basically you pass in a function to this function, and it's called within. It's called by its parameter name, and you just add the parentheses and any parameters if it requires any parameters. This is really cool because you can send functions to any place in your code, and you can call it somewhere else. This is also called like a callback, because you send a function to some place, and then you call back to the originating place when you actually call that function or use that function parameter. Another example here, we have a function called fetch user from repo or a repository. And we have a function parameter called onUserFetched, which is a function type that receives a person object, and it returns unit, or it doesn't return anything. So here we can like have a fake user created from the repository, from like a database or the internet. And we create a user called or a person called Philip Babic, I guess, and we store it in a user object, and then we call onUserFetched with that object. The way we call this fetch user from repo function is the following. We just say fetch user from repo, and we open the parentheses, which basically dictate this behavior, like this function call here. And whenever this onUserFetch function is called, it's actually going to execute this block of code. So this is a way where you can define some behavior at one place and then use it in another. This is the place where we define it, and this is the place where we actually call it. And what's going to happen here is we're going to say fetch user Babic, because we essentially return this object. Hopefully this makes sense. Lambdas and higher order functions are probably the most complex parts of languages or modern languages, but they're really easy to use once you kind of get the hang of them. So just make sure that you try to use them, that you try to figure it out, that you play around with a few examples. As I mentioned, they are generally used for callbacks. So when you want to send some data back or call some behavior when an event happens, you can use them for validators and filters. So basically, to wrap some functional logic that validates your data, or filters your data. You know, if a user contains the letter A in their name, or if it starts with an F or something like that, or if your number is greater than 100 or something like that. They're very useful for this thing called DSLs, or domain-specific languages. These are languages that, similar to what like Groovy and Gradle do in Android, that's a DSL where you define your dependencies, you define your build configuration, and so on. That's kind of what you can use Lambda functions for. The code is very clean. You don't have to write complex behavior or duplicate behavior in multiple places. You can just use the same behavior where you define it in one place and then send it to different places. So it's like you can build complex things, but with less code and with cleaner code. The Lambda parameters that you use, you can list them out. So similar to what we did here, you can list them out by name. You can say this is going to be the user parameter. You can have multiple of them and list them in any name you want to use. Or you can use the it parameter name if you just have one parameter and you don't want to define a custom name. And this is still in Croatian. This is I should have translated this, but basically you can rename this parameter to whatever you want, or you can just ignore the parameter by using an underscore, and we'll see that in a moment, I guess. So let's go to collections, which are one of the most interesting things in any language, and one of the most used data structures. In Kotlin, you have multiple different collection types. And they are generally collections means that they are a collection or a group of objects of the same type, usually of the same type. So you can have like collections like sets, lists, maps, arrays, and so on and so forth. All of these have like different big O complexities, or how efficient they are when you want to return an item, you want to delete, add, or insert an item to the collection. You also have immutable and mutable collections, so collections which can be changed and collections which can be changed by adding new or removing new items. And you also have like a ton of operations that you can run on them to transform these collections. So let's see what it looks like. Let's say we have this list of users. We have the users Philip, Luca, Tomislav, and Goran. We also have a set of users where we have the 4 defined above, I guess, but we also have Philip listed out 3 times. What's going to happen here is that users are going to show these 4 elements, and user set is also going to show these 4 elements because sets have unique elements. You can have the same type of, the same value within a set, essentially. So if you're using strings, you can have the same 2 strings in a set. So this is what happens when we print like user set. We just get the 4 elements like before. But what we can also do with collections, as I mentioned, is we can filter them. We can look up for different behavior. We can like do some complex transformations. So for example, here with the value contains A, we can filter each user where the user contains the letter A. And again, we can also use it here like we did in the second example. So the contains A is going to go through each of these elements. So Philip, Luca, Tomislav, and Goran. And it's going to filter the list for all the users that contain the letter lowercase a. So it's going to filter out the Philip because the name Philip doesn't contain the letter A. And when we print it out, we're going to get 3 elements. Alternatively, as I mentioned, we can transform this list. So for example, if you have the value called first name initial, we can say, okay, we want to take each element of the users list. We want to map it or transform it to get the first letter of each element. So it's going to take Philip. It's going to put it here as the parameter it. It's going to take its first letter, which is the letter F. Then it's going to take Luca, Tomislav, and Goran respectively, and it's going to do the same thing. So this is going to create another list, another collection that just contains the initial letters of each of the elements. And we print it out, we're going to get F, L, T, and G. And finally, we can also use something like maps or tables, basically, if you want to call them that way, where you have pairs of elements. So you can use, for example, we have this value called name to job, which is a map. We say this is going to be a map of strings to strings. We're going to map each name or names of the users, I guess, to their job or job titles. So we're going to say we want to map the name Philip to the compose developer as the job title, or Luca to Android developer. And when we print that out, we're going to get this kind of structure where we have Philip equals compose dev and Luca equals Android dev. Basically, this is called a key in the pair, and this is called a value. So when you want to look up a map, you just say, okay, I want to get the name, the title of the job for Philip. You just say map, and you pass for Philip. You just get that key, and it's going to unlock this value. So hopefully that also makes sense. Again, collections are very complex, and there are many of them. They're also like very important for all the algorithms that you use, all the data structures that you use. They're very important for a bunch of different things. So I would definitely like suggest that you dive into collections a bit more, and then you try to play around with them. There are many different books that you can read, such as well, I guess design patterns in general. You can also read Thinking in Java. You can read books like that. So basically, books that talk about data structures and algorithms, or like languages, and within them the structures and algorithms. You can learn about them a bit more. And I think finally we'll kind of go into the idea of delegates. Delegates are also something that's very unique to a few languages, I guess. Not every language has them, but basically the idea is that you like politically, let's say, delegate the behavior or the implementation of a property or a function to another class. So you define the behavior, or like you define the abstract behavior in one place, and then you say, okay, I want to take this behavior, but it's going to be concretely defined in another class. So for example, like get and set functionality to fetch a property, to fetch a value. You can define the property in one class and define the get and set functionality in another class, which is called a delegate. You also have these delegates like lazy, observable, and map, which basically allow you to instantiate the value in a different way. So lazy lets you instantiate it the first time that you use the value. Observable lets you observe the changes, and map basically lets you like map values to keys, or sorry, keys to values. So let's take a look at how, what it does. So for example, we have a lazy delegate here where we say, I want to define a value called expensive object. Expensive in a sense that it's hard to initialize because it's like an expensive operation. It's going to be lazily delegated, which means that the first time that I use the expensive object property, it's going to call this function within this Lambda block, and it's going to produce that value. So this is really cool when you have things that you don't want to create right away because it's a long operation, because it takes a lot of memory, but you want to define how it's going to be created, because you might want to, or you're going to have to use it eventually. The observable delegate is also really cool because you can observe the changes of the property. So for example, I have the variable here called name, and it's using the delegates observable. The initial value is going to be Philip, and then we have this like property, old value and new value parameters for this Lambda function. The old value and new value parameters are really important here. So basically you say, okay, the old value is going to be this one, the new value is going to be this one. And whenever you change the name to something else, it's going to run this block, and it's going to say, okay, the old value was, let's say, Philip, and now it's called Luca, or now it's called Tomislav, or something like that. Basically, whenever you change the value, you get the updates. That's why it's called observable, because you can observe the change. And finally, as I mentioned, the map delegate is really cool because you can say, okay, I have a map here called name to job. And again, we were going to use like Philip to compose dev and Luca to Android dev. And then I say, I have this property called Philip. It's a value, and it's delegated by the map. So basically, it's going to use this map to fetch the value for that key. The key that it's going to use is actually the property name. So if you call it Philip, lowercase, it's going to use this, this property here. If you call it Luca, then it's going to use this value. So this is really cool because you can say print Philip, and it's going to print compose dev, and it's going to do that every single time. And if you change the value for the Philip key, it's going to also affect what's printed out when you call print line Philip, which is really, really cool. So you don't have to like build complex behavior where you always call like name to job get this key. You can just say, okay, print this value for me. So this was like a bit of a shorter talk because again, as I mentioned, there are so many different topics within Kotlin. There are so many different advanced topics that you can talk about for hours. So hopefully I managed to like explain some of the more complex parts of Kotlin, some of the more advanced types, some of the more commonly used types, I guess, because it's object-oriented and functional programming in one place. But again, if you have any questions or you feel that I missed something or you're not really sure what about something that I explained, just please let me know and I can answer that. And yeah, thank you for listening. I hope we do this again. Maybe I can prepare some more presentations or something more specific if you want in terms of Kotlin. Oh, well, we had 2 questions already, so I'm not sure if we're going to have more. So I can just jump into that real quick. The first question is it possible to execute Kotlin program without JVM? So there's this project called Kotlin Native or Kotlin Multi-Platform Mobile in general, just like Kotlin, Kotlin, which is used for like non-JVM stuff. So in essence, you can kind of run it natively, but the most common, but it's usually like for specific types of projects where you want to reuse code for, let's say, mobile apps or reuse code for the web or something like that. So yeah, you can run Kotlin in like a native way, but it's most commonly used on the JVM for Android or on the JVM for like backend solutions, I would say. And the second question is, what is the difference between iterable and a sequence? So this is a really good question. You have these two like collection structures, I guess, in Kotlin, which are called like iterables and a sequence. Iterables are all like basically they're like hot solutions, so to say, where you create an iterable and you already like allocate all the memory for all the values in your program, and you also iterate over each item essentially like consecutively. So in the filter example, if you were to change multiple operators like filter, like map, and so on, you would have to call each of those operators in line. So basically, you will have to first call filter, then you will have to call a map, then you will have to call like filter again or something like that. Sequences are lazy collections, and they don't allocate the values for like initially or like immediately. Instead, what they do is they allocate the values as you use them. So if you were to do the same in a sequence where you have the filter function, then the map function, then the filter function, instead of going through each of those functions like consecutively, like filtering all the items, then mapping all the items, and so on, it's going to do it in like a vertical order. So for the first element, it's going to call filter, then map, then filter. For the second element, it's going to go filter, map, filter, and so on and so forth. Basically, this way, it's like a more lazy structure, and it's more performant usually to use sequences instead of iterables, because they do this like lazy computation. So they don't allocate all the memory ahead of time. They just allocate it as needed, which is really, really good for you as a developer. So hopefully that kind of like answers it. So what is a class? Basically, we covered this in the last presentation, I think. A class is generally described as like a blueprint for building objects. It's a way to combine behavior and combine state into one like definition, so that you don't have to so that you can like reuse behavior. So for example, if you create a user class, you always know that the user is going to have like an ID, the name, the last name, maybe some extra state like an email, maybe you have some behavior like fetching its image or something like that. Basically, you define the user type, you define the user class, and you always know that when you use a user, that you're going to have these properties. And this is much better than just like sending a string which has a bunch of data, because then you have to parse the string. And what happens if one user doesn't have a name and your parsing or your reading from the string doesn't work, and so on and so forth. So basically, you want to use classes when you want to define behavior that's always going to be the same, or you always want to know what the type is. So hopefully that answers the question a bit more.
Actually, the questions are over, sir, and yeah, I hope you guys like this event. And if you want any event regarding the topic in the Kotlin, you can just submit in the form below. And yeah, thank you for watching this live. And yeah, thank you. Bye bye.
Yeah, thank you.
Thank you.